In this video, we're going to talk about naming conventions of triangles. So we have a right angle triangle here on the right hand side of the screen, and a lot of the work we're going to be doing in the near future is going to be specifically with right angle triangles. So we already know that we can name a triangle by labeling the vertexes with capital letters. Likewise, if I pick one of the vertexes and I go directly across the triangle to what's called the opposite side, we can give that a name, and often we'll give it the lowercase letter. So again, if we take B, we'll go right across to the opposite side, and we'll call that small case b. If we take C, we'll go right across to the opposite side, and we'll call that C. So now I have a way of labeling a triangle in a manner that's consistent. So if I'm talking about vertex A or angle A, I can also talk about side A and have an idea of which one that is. Now, we want to introduce some new terminology here, which you've heard, but we haven't really formally defined. And we want to talk about the opposite side, and we want to talk about the adjacent side. You're already familiar with the hypotenuse of a right angle triangle, and the hypotenuse of a right angle triangle is simply the longest side. We talked about at the start of this video how if I'm looking at angle A and I go directly opposite to it, this would be side length A. So the opposite side is the side that is directly across from an angle. And so the first thing to know about the opposite and adjacent side is that it's subjective to the angle you're talking about. So the opposite angle for the opposite length for A would be small a. So we could say the opposite for angle A is small a, or we could say that as BC. Now likewise, if I took angle B, we would talk about the opposite of B, and that would be small b. So the opposite for angle B is B, or we could say AC. Now with this new terminology, we're working with right angle triangles, and we will never really refer to the hypotenuse as the opposite side. This is always the hypotenuse of the triangle, and that's an important idea to get. We always want to talk about one of the non-90 degree angles, or the non-right angles, in this case B or C, and then talk about the opposite and adjacent with reference to that angle. So now we talk about the adjacent side, and the adjacent side is the side that isn't the hypotenuse and isn't opposite. So in this case, if I took angle A, the adjacent side would be B. The adjacent side is always makes up one side of the vertex where the angle is. So the adjacent for angle A is small b, or we could say AC. And likewise, if I take angle B, the adjacent for angle B is A, or BC. So the key thing is that the opposite side and the adjacent sides are subjective to the angle that you're discussing, and that's really important. So just as a quick little example here, if I do a right angle triangle, and let's say we had this as a 3, 4, 5 triangle, and let's call this ABC. In this case, the opposite of A is, and we can go from A directly across, is 4. The adjacent of A is, and again, I start from A and just go right next to it, is 3, and we know the hypotenuse is 5. The hypotenuse doesn't change. So now if we let's say instead of talking about with reference to angle A, we want to talk about reference to angle B. drawn on there. Let me draw that out again. Well, if we're talking with reference to angle B, the opposite, we'll just shorten it to OPP. Opposite of B is 3. The adjacent of B is 4. And notice how they switched from the case when we're talking in reference to A, and the hypotenuse remains 5. So though this seems rather trivial, being able to identify the opposite and adjacent and hypotenuse effectively is key to moving forward with trigonometric primary ratios. Good luck.